Okay, so today I will be going through exam style questions on bonding, structure, and properties of matter. I'm just going to do this in parts. So this will be part 1, answering all of question 1. If you're in year 9, year 10, or 11, this will come really handy. Okay, so straight on to question 1. By the way, if you've not liked or shared, please like, share, and subscribe. Really important, helping my channel. Thank you. Okay, so the first question says, this question is about carbon and compounds. An atom of carbon is represented as, so we have the mass and we have the atomic number. So the key thing is to always remember that when you have the numbers, okay, sometimes they write the larger number at the bottom and the smaller number at the top. Just remember that the larger number is a mass number and the smaller number is the atomic number. So the question says, what is the number of protons in this atom of carbon? Now, if you don't know, your mass number, which I'll represent as M, so let me just write it in full, mass number is equal to the number of proton plus the number of neutrons. But atomic number is equal to the number of protons, and it also tells you the number of electrons. So bearing that in mind, then our atomic number is the number of protons. Okay, so we'll tick 6. What is the number of neutrons in this atom of carbon? So if I say that my mass number M is equal to the number of protons plus the number of neutrons, I know that the mass number is 13. I know that my proton is 6. So what would you add on to 6 to make 13? And that will be number of neutrons, so I'll tick 7. Okay, so moving on to question 1C. So remember that what we had was carbon, the mass number at the top, atomic number at the bottom. Now the question says, what is the number of electrons in this atom of carbon? As long as that atom has not been involved in any reaction, the number of protons is equal to the number of electrons, so we're ticking that as well. Okay. Now for this one, figure 1 shows the structure of a carbon compound. So this is a carbon compound, but it happens to be bonded to halogens, which are fluorine, right? Complete the formula of the carbon compound. So basically, count the number of carbon atoms present in here. So we have 1 and 2. So here will be 2. And then we have 4 fluorine atoms bonded. Sorry, 6 fluorine atoms bonded to the 2 carbons. So 1, 2, 3, 4, 5, 6. You have it as C2F6. Okay, next question. Methane is a carbon compound. It exists as small molecules and it has a low boiling point. What is the reason for the low boiling point of methane? Tick one box. So, covalent bonds and intermolecular forces are weak. Now, covalent bonds are not necessarily weak. However, intermolecular forces are weak, so this will not be our answer. Now, only covalent bonds are weak. No, again, like we said, covalent bonds are not weak, so cross that out. Now, only intermolecular forces are weak. So yes, the intermolecular forces are weak. And that's why carbon compound will exist as small molecules and they have low boiling points. Okay, next one. Buckminster fullerene is a form of carbon. You need to remember that carbon has different forms, so you can have it as fullerene, you can have it as graphene, graphite. Okay, so these are all different forms of carbon. Now, What is the shape of a Buckminster fullerene molecule? So this is something that you just need to read and remember. Okay, so the Buckminster fullerene is always spherical. This is something you just need to know. You need to remember that it is spherical. Okay. Now, graphite, remember, is I said earlier, is also another form of carbon. So when we take a look at graphite, figure 2 represents the structure of graphite. So this is graphite here. How many covalent bonds does each carbon atom form in graphite? Okay. So this circle, each circle is a carbon atom, right? You'd observe that it has one bond. Each line represents a bond. So one bond running from that circle to another, and this bond running from that circle to another, and then there's another bond this way. So in total, we can count 3 bonds. So again, I'll just show us that with another circle. So in graphite, every carbon atom has 3 bonds. There's one bond running that way, one running that way, and one running this way. So 3 bonds. So we'll tick that. You just need to remember that these lines represent bonds. And then the last question for this part, diamond is another form of carbon. Figure 3 represents the structure of diamond. So just a quick one, we have the different forms of carbon that you can find are fullerene, graphite, graphene, which is part of graphite, and then we have diamond. These are all forms that you need to remember. Now, where graphite has 3 bonds, okay, from one carbon atom, so the atoms have 3 bonds. Here, diamond has 4 bonds. So each carbon atom has 4 bonds. So you have 1 bond, 2 bond, 3 bonds, and the 4th bond is here. If you pick another carbon atom, let's say this one, you have bond 1, bond 2, bond 3, bond 4. Okay, so each line represents a bond. Okay, so now let's move on to the actual question. The question says, describe the structure and bonding in diamond. Remember that these are 3 marks questions. So basically, they expect 3 important points from you because this is 3 marks. So I'm just going to rub this off and then I'll write out the 3 points that are expected. Okay, so point number 1. If you look at the structure, because it says you want to describe the structure and the bonding, okay? So first we're going to get 1 mark from the structure. If I look at that structure, I would say that it has a giant structure. Diamond, it has a giant structure. Even if you said that it has a giant lattice structure, you would also be right, okay? So that's 1 mark straight away for talking about the structure. And the next mark comes from talking about the bonding. Okay, so atoms are joined by covalent bonding. Because you need to talk about what type of bond. I know I said that each line represents a bonding, but what type of bond does it represent? Because remember, we have covalent bond, we have metallic bond, we have ionic bonding. So here would say atoms are joined by covalent bond. Okay. Now your 3rd mark will be coming from one more information about the total number of bonds. Okay, so you would say I've shown us earlier that each line represents a bond and each carbon atom has 4 of those lines extending out from it, so 4 bonds. So your 3rd mark will be each carbon atom forms 4 bonds. Okay, and that brings us to the end of this session. Please like, share, and subscribe. Thank you.